is. All right, so I was just saying that homework B5 has been, so Unit B, we're just starting Unit B, and homework B5 is, or we're going into Unit C, so homework B5 has now been assigned. By the end of this lecture, you should have all the tools you need to complete that homework. It's due in about 2 weeks. See Canvas for details. And then the next lecture, so before we end Unit B, I want to make sure we have a little more practice at these things. And so the next lecture I'm calling a lecture size. And this lecture was originally built to be totally asynchronous. And so there was an opportunity for, well, it doesn't matter all the details, but because of that, it's kind of built like an online course would be built. So it's like there's a couple, if you go to the lecture B5A on Canvas, you'll see that it's actually a Canvas quiz. And if you go to the quiz, then it's broken up into multiple small vignette videos with a couple of questions in between the little vignettes. And so those completing those questions gets you the attendance exercise or attendance credit for that lecture. So what you can do on Tuesday is you can come to class and I will give it live, and instead of fulfilling out attendance exercises, you can just I'll give you time to actually maybe even work in breakout groups for small bits of time to do those little questions in between the vignettes, except the vignettes will be for me. If you don't want to come to class on Tuesday, then that's fine. You can watch the entire lecture size on your own and answer those questions. It's a very low stakes, I mean, it's not a quiz, it's just organized like a Canvas quiz. It's just one single attendance credit, but you know, so it's a couple of questions. So you can view it as kind of a totally online asynchronous lecture that we will do live because I'll be here, and so may as well. But if you don't want to do it live, if you'd rather watch it on your own or do it ahead of time, then that's fine. If you've already done it, because I noticed some people already looked ahead and have submitted it, and you feel like you're okay with all this stuff, then again, you don't have to come. It won't hurt my feelings. So that's what's coming up there. And then what's beyond that is lecture C1, which will be Thursday, a week from today. And that's going into Unit C, where we go back to the old book or the normal class textbook, where it is where we'll be focused more directly and squarely on sustainability, pollution, abatement, etc. And so there is an activity that is due before the start of C1 that's out there and available for you to do. All right, so that was a lot. Are there any questions about that? So again, on Tuesday, we will have the Zoom class as usual. But if you would like to be totally asynchronous, you can actually already do Tuesday's whole experience by clicking on the lecture B5A in the module for Unit B. And then you can just watch a couple of minutes, and then it asks a couple of questions, and a couple of minutes, a couple of questions, and it's kind of meant to be a totally asynchronous version of a lecture with attendance exercises interspersed. And it's just meant to give practice because we're going to start getting quantitative in this lecture. And by quantitative, we're calculating stuff. All right, so last time we showed how you move from indifference curves into demand curves. And so we said you've got these indifference curves, like over here on the left. That's, these curvy lines are all of the bundles that from the Birkenhelfen, these are all of the ways that you would be willing to give up or take on more electricity consumption if it meant swapping out with consumption on other things, and you would be equally happy with those. And so, so that's what we kind of see here. And we said that this bold line, that's the budget constraint line at one price, and this thin line is the budget constraint line at another price. And so as you change the price of electricity, then it's still anchored at the same point on all the other commodities because their prices didn't change, but it rotates down, and so the point of tangency moves down. And so for these two different prices, price 0 and price 1, you get two different levels of electricity consumption. say 2.64 and 1.81 megawatt hours. And so we could imagine sweeping the price through a large set of these things, and we could end up saying for every price of electricity, assuming nothing else changed, we could figure out every amount that someone would be willing to spend. So as electricity gets cheaper, they might change their attitudes on electricity consumption. As electricity gets more expensive, they might start conserving a lot more, and we could sort of understand that. And we can plot all of that out on this thing that is going to be this demand curve that shows up here on the right. But right now I'm only showing those 2 points. So I've got price 0 here. So at the original price, you consumed this much. But at the increased price, sorry, I got that backwards. At the original price, you consumed this much. And then, but then if they increase the price, you reduce your consumption. And so, so this is reflecting that. And if we keep going, then for all of these prices, we could then study how consumption changes and then fit a curve to it. And that's the so-called demand curve. And when there's diminishing marginal returns, the demand curve will have this bowed-in convex shape again. So an convexity becomes a tool that economists use to describe these things. And so the demand curve here, this we're going to get more into this into chapter 2, thinking of the demand curve as what we will later call a marginal benefit curve. And the marginal benefit, the benefit to one more unit of goods, is going to be highest when you don't have much of that good. And so this demand curve says when you don't have much electricity, the next unit of electricity is worth this much. But if you already are using a whole lot of electricity, the next unit of electricity isn't going to be worth as much. And so this relationship between price and consumption is really a relationship between willingness to pay and consumption, which is a measure of your values. And so that's what we're getting into today, and then how do we do calculations based on that? So this is the so-called famous demand curve, and the demand curve is associated with the demand function. So demand function is just a mathematical way of writing the demand curve. And so we could figure out a mathematical function for how to write this thing out. And that demand function is going to be, and that's why I put F for function here, it is going to be some expression which relates the price of the good to the amount of quantity that is demanded, the amount of quantity that someone is willing to buy at that price. So if it's 7 cents a kilowatt hour, this is how many kilowatt hours you'll buy. This demand curve that's being shown here is an aggregate demand curve, which is why it's in terms of megawatt hours. You know, so it's like how much is a group willing to buy, but it's still the same sort of thing. For a given price, how much are you willing to buy at that price? So the function is actually, even though this is demand curve, the function is sort of being interpreted in kind of an inverse way, where the input comes in on the left, where like if price you view as your independent variable, it comes in on the left, and then the output comes in on the bottom here. And so it's just tends to be convenient to plot quantity on the x-axis and price on the y. And so even though we refer to the demand function, the demand function maps price to quantity, the demand curve is usually plotted where you've got quantity on the x-axis and price on the y-axis, but they're the same thing. Okay. So changes in price lead to changes in quantity demanded. So this is some terminology that those of you who've already taken a micro course should have had beaten into your heads, is that the changes in a price does not change demand, it changes quantity demanded. And so it's not that my demand curve has changed when you change the price, it's that the amount that I'm willing to buy has changed because you changed the price. And exactly how much I'm willing to buy is defined by the demand curve. So a change in demand means that you're changing your relationship to price. But a change in price just changes how much you buy of that thing. So a change in demand is not due to the change in the price of a good. It could be due to things like a change in income or a change in the price of other goods, or a change in utility, a change in your preferences. So these are all things that shift the curve as opposed to things that move along the curve. So changing the price of a good moves along the curve, changing everything else moves the curve. And we just have to remember that behind the scenes, there are indifference curves driving all this stuff. And so if we want to try to remember how this all works, then we know that if the indifference curves and the price of the other goods are staying the same, then changing the price of the current good is just rotating a budget constraint line. And it's just reaching tangency with different indifference curves. And that's what's changing the quantity demanded. But the change in demand is actually moving the budget constraint line or moving the utility curves, moving the indifference curves. So if you get a change in income, it's not that your budget constraint line rotates because the price changed. If you get a change in income, the whole income curve moves, even though the prices haven't changed. And it's that income shift which so-called changes your demand. You now have the ability to demand more because you make more money, for example. So, and then with that change in income, we can do the rotation exercise. And that rotation exercise at your new income will give us a new demand curve. And that's just what I've drawn out here, where here's our old demand curve, where we took our old income and we tried all the electricity prices, and they gave us this curve. And then we added to our income, so now we could afford more. And then we did all of the prices of electricity and saw how much we bought. And then that gave us our new demand curve. So that's what we mean by changing demand means moving the curve, whereas changing price just changes the amount you demand, the quantity demanded, which is moving along the curve. Okay. So are there questions about that? Does this make sense what I mean by?
I got a question real quick.
Yeah.
So wait, explain how the change in income leads to change in demand, like from the old QP to new QP. How did that happen again? I was lost for a second.
Right. So so if we go back to our indifference curves on the left side of the page here, then a change in income. So maybe it'll be clear if I go back a slide or two where I don't have multiple blue lines. So if we look at this slide here, the black curvy lines are the indifference curves, which represent my preferences.
Mm-hmm.
The place where these two black lines intersect the stuff axis represents how much stuff I can afford on my current income.
Okay.
If I get an increase in income, I can now buy more stuff. So if I change this to a pin, then the amount of stuff that I can buy is going to increase at my new income level. And that will end up connecting to this blue line here. So imagine that, so forget I drew that, imagine I drew it way up here.
Okay.
So by getting more income, I shift my budget constraint line up. And I also can now afford more electricity. So I shift my budget constraint line kind of up and over. And so this shift in the budget constraint line means that I used to buy this much electricity, but now I reach a point of tangency up here and I buy this much electricity. And so, okay, that's fine. So that's how much electricity I buy at this electricity price. Well, what I can do then is if I just focus on the blue curve and where it's anchored way up here, I can say, what if I change the price of electricity at this new income level? And so at this new income level, then if I increased the price of electricity, then I've got this new blue curve down here. And so at this new income level, if I increase my price of electricity, I can buy less electricity, but I'm going to rotate around a point that's higher on the stuff axis. And so this is how much electricity I would buy at my new income level at the original price. This is how much electricity I would buy at my new income level at the new price. And so we can see these two big points are different than the old points. And that corresponds to having a different demand curve. And so these two black points here correspond to these two black points on the green demand curve. And this red point and this magenta point correspond to this red point and this magenta point on this blue demand curve. And so getting a newer income shifted my budget constraint line, but it also shifted all of the points of tangency as if I would rotate that.
Okay. Thank you.
Any other questions? And another way to think about what we mean by a change in demand is that when your demand changes for the same price, you will get a change in the quantity demanded. So in this case, for the same price of electricity, at our old income level, we bought this much, and at our new income level, we buy this much. And so I didn't change, if I didn't change the price of electricity, if I only increased my income, and I saw an increase in how much electricity I bought, that must be due to a change in my demand for electricity. So my quantity demanded changed not because I moved along my demand curve, it's because my demand curve moved. So when that happens, when your income increases and your demand increases, we call that a normal good. So electricity might be a normal good, but it turns out that electricity doesn't increase, that as your income increases, you maybe don't increase your electricity use that much. So there is somehow some notion that some goods are going to be more sensitive to income than others. And that's kind of what we're going to start to quantify today. So there's another type of good called an inferior good, and it flips the other way. So as you get a change in income, without us going back to the indifference curves, you just have to take my word for it at this stage. Like we did talk about what the indifference curves might look like last time, but without going back to the indifference curves for now, and I'll end up showing the indifference curves here in a second, but this is the way you're kind of supposed to think, is that the way you think about an inferior curve is one that where an inferior good is one where a change in income causes a downward shift in the demand curve. And it might seem weird that I increased my income and now I generally spend less on a good. But if you think about it in terms of indifference curves, there are shapes of these indifference curves where this will happen. And so I've got one drawn up here where it just so happens that if your indifference curves kind of have this separation where they get kind of more and more separate up here, if you were to draw your original budget constraint line and then your increased budget constraint line, then what you'll see is the point of tangency will cause one of these things, the inferior good, to actually decrease in the amount demanded of that good. And a lot of times these are things that, if you want to conceptualize it, these are things that you might think would be more attractive when you're on a lower income. So you might buy used cars or secondhand furniture when you're in college, but maybe when you become more stable in your careers, when you have an income that you're more confident is going to meet all of your needs and continue to meet your needs, you might say, well, let's substitute our used cars for new cars, for luxury cars. Let's buy new furniture. Let's stop going to IKEA and start going to those furniture places where normally you walk in the doors and you didn't know couches could cost that much, but you start considering those and you stop buying the other things. And so those are so-called inferior goods, goods in which you kind of buy more of them at lower incomes. And as you get higher incomes, you buy less of them. And so they're not bad goods, just for whatever reason, economists call them inferior goods. It's kind of value laden. So that's a good term that you should keep in mind. Now there's a really interesting extreme case of inferior goods. Imagine if your inferior good, let's say your inferior good is something like rice or bread. These are staple foods. These are foods that are in everyone's diet. And if you've got nothing else to eat, they might be all that you eat. Now what might happen if we combine an inferior good that's a staple good with a price increase in that good. And that's what happens. That's what the so-called, we get these things called Giffen goods. And Giffen goods are really weird because if we think about this, and I think, and I'm kind of maybe cutting ahead and kind of giving away some of this, but if we think about like what's happening with rice, if you raise the price of rice, people will still keep buying rice because rice stays in their diet. But what happens when people keep buying rice and rice is at a higher price? What other things might happen with those people? Like, does anybody have sort of an idea of where I'm going with this? Let's think about everything you could put in your kitchen. Let's say you always know that rice is going to be in your kitchen and somebody raises the price of rice. What else is going to happen to your kitchen because you continue to buy rice and rice is at a higher price? Does anybody have ideas? They spend on other things. I see one thing. So anybody have, yeah, so anything else anybody wants to add to that? Other things that they might buy or not buy? I see some great answers so far in the chat. Anybody else? I mean, the chat is kind of, there's not a whole lot of diversity of what I'm looking for here. Right. Good, good. So things that are popping up in the chat is that they're spending less on other things, less meat and veggies, less pasta, less bread. They're buying less of those things. But here's, okay, so now let's think dynamically about this. All right, fine. I can't afford bread. Bread's also a staple crop. I can't afford pasta. Let's do that. So I now had to spend, you raised the price on rice on me. So now in order for me to buy more rice, I have less money available to buy pasta. And so I just can't buy any pasta anymore. But I still need those carbs. So what am I going to do? If I can't buy pasta because they raised the price of rice, what might I do to deal with the fact that I can't buy as much pasta that I used to buy? I'm thinking dynamically about this here. You raise the price of rice. Or to set this up a different way, I buy this much rice, and this much rice costs a certain amount. Well, then they raise the price of rice. I buy this much rice and it costs more. That means I can't buy any pasta anymore, but I still have this much rice. Well, this much rice isn't going to feed all of my calorie demands. And now I can't eat pasta because this rice prevents me from buying the expensive pasta. So what do I do to meet my calorie demands? If I can't eat pasta because I had to pay a little more for this much rice. Anybody have any thoughts?
Could you repeat that again? Sorry.
Yeah, no, so the question is, I buy a pound of rice, or a gram of rice, or whatever you want. And I'm seeing some chats coming in here, so I'm just going to repeat that. If I bought a pound of rice and it was, I don't know, $1, and they raised the price of rice, now my pound of rice is $2. Now I only had a $3 budget. Now when I had a $3 budget and I bought $1 of rice, I could buy pasta. But now I can't buy pasta because all I have is $1 left. But I still need calories. So how do I deal with the fact that I now have to spend more of my budget on rice and I can't meet my calorie demands with pasta? And I see a couple things coming in, like people saying, find another cheaper good to purchase. If you have to buy, if you have to buy the rice, replace the pasta with something cheaper. Find an alternative to meet the calorie demand. These are exactly where I want you to be going with this. But one next step is, do you happen to know something that's cheaper than pasta that I could buy more of? That I've already talked about? Rice. That's right. I can buy more rice. So imagine that. They raise the price of rice and I buy more rice. That is a Giffen good. So what we've done is by raising the price of rice, it's cheap. It's already a cheap good. And it's so cheap, I buy a lot of it because I have a low income. Now I can splurge a little bit on pasta. Now they raised the price of rice. I can't splurge on pasta anymore, but I still have some money left over in my budget. And so what am I going to do? Well, I can't buy anything else. I might as well buy the cheap rice. So now we're just going to eat all rice and no pasta. So a Giffen good is a weird inferior good in that not only it doesn't have this effect where as you increase income, you decrease consumption, but it almost seems to violate the so-called law of demand in that you increase price and you buy more of it. And so it seems to be contradictory. It also seems like people are buying goods because they're more costly, but that's not it. Nobody's buying more rice because they're excited that rice is expensive. They're buying more rice because the rice they have to buy kept them from buying anything else. So if rice were cheaper, they could buy more, they could splurge. But now the rice is more expensive, they can't splurge. So what are they left with? Rice, and they just buy more rice. So that's a so-called Giffen good. It's a special type of inferior good. It's an extreme case. And there's a question, up to what point? Yeah, I mean, eventually you buy all rice up to your budget. And if your budget doesn't support your calorie demands and you don't have any other cheaper options, then you end up having nutritional imbalances. This is kind of what we mean if we want to talk about food, what we talk about with food desert, like that, you can go, if you're, you can have these virtual food deserts where, you go into a grocery store and there actually are things available there that will meet your physiological needs, but you can't afford them. So they may as well not be there. And so eventually something's got to give. And so, what's cheaper than rice but gives you a lot of calories? Twinkies, high sugar goods. So if really you're being driven by the fact that you need energy, then yeah, you can just buy a lot of cheap, high sugar stuff. But that's going to end up, that leads to diabetes and other things and whatever. And so, yeah, there's a lot of other things we can talk about just with respect to food. And so, but before we talk about that, I want you guys to start thinking quantitatively about substitutions. Is that as you make one thing more expensive, how does that affect a person's relationship to the substitutions to those things? And how does that then have a dynamic effect back on the thing that we originally were focusing on? And that's why I'm bringing up Giffen goods. So any questions about that? Is that pretty clear what I mean by Giffen goods?
So, just want to clarify one thing about Giffen goods. So basically, like if a rice ended up becoming a Giffen good, it just minimizes your choice or preference of certain things, right?
It is something that it's so cheap that you're going to buy it anyway. And because it's going to be in your consumption bundle anyway, then the opportunity, it is going to put a tremendous opportunity cost on you. And so that's kind of the thing about it, is by making it more expensive, it prevents you from taking opportunities for substitutions. So when it's cheaper, you have more substitutes available. When it's more expensive, there are less substitutes available, but it's still available, and that's why you spend more on it.
Okay.
Okay. All right, so we kind of walked through my next slide, which is like an explanation for why staple foods are Giffen goods, but I hope that's clear to everyone that staple foods, because they're almost always in your budget, are probably going to be Giffen goods, because they're an inferior good. They're something that if you had a higher income, you probably wouldn't buy as much of it. But they're also a Giffen good in that if you had to buy it, if you had to meet all of your demands with these goods, then they are going to prevent you from buying the substitutes that you could splurge on, and you'll just end up buying more of them instead. I just want to point out here that price is not acting on utility here. So that we didn't change the utility functions to make this happen. This was it really is a demand curve, which is, in the wrong direction. It's a funny shaped demand curve that is due to this substitution effect. And it's this interaction in this indifference space. Now, on the opposite end of the income spectrum, when you're making a lot of money, then you can now start affording things that actually have value that is tied to their price. You can imagine some goods, once they get so expensive, some people buy them in order to show off that they can buy them. And the more expensive they are, somehow they become more attractive. So this is another weird type of good called a Veblen good. And in this case, you can think of it as when price interacts with social status, price is actually changing the utility of the good. So you had a certain set of indifference curves, but those indifference curves are related to the price of the goods, the things on the axes. And so if you change the price of the goods, suddenly that good becomes more exciting than it used to be. So, for a normal good, then if you increase the price, the indifference curves don't change. So for a normal good, increasing the price just moves the budget constraint line around. For a Veblen good, then you get a weird effect that not only are you rotating the budget constraint line around, but you're actually changing the slopes of these indifference curves. And so you're changing them in a way that makes the pricier good more attractive. So you're suddenly willing to give up the cheaper thing in order to get more of the pricier thing. And this happens to also have an effect that appears to violate the law of demand. And this, I think is a true kind of violation here, because it is just this, totally, well, you could argue this is totally irrational behavior. In the case of the rice, you kind of get it once you talk through it. In the case of this, you're like, man, you're just using price as a signal, and so you're buying something because it's more expensive. That really does seem like it's like some weird irrationality. Now we can wrap something rational around it, because maybe you'll end up benefiting later on in life if somebody sees you in this expensive car or whatever. But at least in the shorthand of things, it appears to totally violate economic thinking, that your utility curves will actually change to make you more, to shift your preferences toward pricier things. And that's a Veblen good. So it's very, very different than a Giffen good, although it also has this strange effect where if you increase the price, it appears to increase the quantity demanded. So is that clear? That there's a difference between those two. In one case, price is not attractive, but price is important. In the other case, price is actually the attractive feature that you're buying. Okay. All right, so the other term, the other function that we worry about here is inverse demand. So we've got this demand curve, it's the same demand curve, but sometimes I ask you, for this price, what quantity would someone be willing to buy? But very often we also ask the other thing, is from Q to P, is that at what price would someone be willing to buy this quantity of goods? Or it's a question of value. And so the question is, if someone had this much electricity, how much would they value the next small unit of electricity? And that's really what we're saying here with the inverse demand function, is I give you a quantity of how much you already own, and it spits out how much you'd be willing to pay for the next tiny increment of that good. That's the inverse demand. So those are the two functions that we're going to be throwing around here. We have a demand curve, which is this whole curve here. And then we have two ways of representing that curve mathematically. Either as a demand function, where P shows up on the right-hand side, and then there's a function of P which spits out Q. Or we can flip that around and we can put Q on the right-hand side, and then P comes out the other side, so that for a quantity, it gives us the price out. And if you go back to, maybe in high school, you might remember taking inverse functions. So somebody might have given you a function like y equals 5x plus 6, and they might say solve for x. And so, and then if you solve for x, you get a function of x in terms of y. And that is viewed as the inverse. If you were to graph that first function, the second function is viewed as the inverse of the first function. And that's exactly what's happening here. I can give you a demand function, and by solving for price, you then can give me an inverse demand function, or vice versa. I can give you an inverse demand function, and by solving for quantity, you'll give me a demand function. And there's a question. So the curve can be drawn as demand or inverse to get the same image. Yes, thank you for that question. It is the same curve in either way. It's just here we're putting price on this axis and quantity on this axis. And so if we always plot price on that axis and quantity on that axis, it doesn't matter which function we choose, it'll always look this way. Now you can plot an inverse demand curve or something. So this technically is an inverse, but you can plot this the other way. You could plot price on the x-axis and quantity on the y. But for a number of reasons, it ends up being more convenient to plot quantity on the x and price on the y. And that's why we do it. It just ends up being more convenient. So there are questions about this, about these three things, the curve and the two functions that represent the same curve.
I have a question, but going back to Giffen goods, if that's okay.
Sure.
It's been like trying to contemplate in my head. So I know that since bread and rice would be considered necessities versus something that's a choice, that's why it would be considered something that you'll still pay for if the price goes up. But what I'm confused about, I guess, is let's say we were given a problem. I don't know if you'll be distinguishing the difference in the future, but how can you tell the difference between something that you're assuming the person will get anyway versus something that's like a quote unquote choice? Because I guess in real life, if the price went up, they might not purchase it if they actually their budget is what they have to eat in overall, if that makes sense. So I guess I'm confused about how to distinguish, is there just things we're supposed to assume in any problem or context are labeled as inferior goods, or what is it subjective to in terms of change?
Right. Well, I guess so. The label inferior good, we kind of stamp on something post hoc as a causal explanation for why we see something. So let's say you run a grocery store and you look at all of your sales data, and your sales data said, we noticed last month we increased the price of rice, and we were expecting that when we increased the price of rice, that the quantity demanded from us of rice would actually have gone down, because that's how everything else works in our store. But they noticed that actually people bought more rice. And so what economists do is that they, remember it's kind of normative positive economics. So economists look for economic descriptions of what the heck happened. And an inferior good is a causal explanation that tries to explain what's going on here. And the inferior good explanation is that the people who came to your store had enough budget to buy more rice, but they did not have enough budget to buy rice and pasta at the new price that you gave for rice. And so, I can't say that rice is always an inferior good and you're always going to have enough budget to buy more rice. I think your kind of point is that, if you've got a very low budget and you are already buying the most rice you could possibly buy and you weren't buying anything else already, then changing the price of rice, the only option is to buy less rice. And that's true. That's absolutely true. But we are talking about if we view a demographic of people who is not necessarily in that bad of shape. They have a food budget, which normally they would spend on rice plus other things. in that demographic of people who would normally have a consumption bundle that includes rice and other things, if you raise the price of rice, rather than seeing a decreased amount of rice consumed, what you may end up actually seeing is that they will decrease other things because now they just can't afford those other things at all. And then they have to fill in the gap, and then they fill it in with rice. But view it as a explanation for why we might see that in the data. Don't view it as a prescription for like why or how people act. Does that help?
Yeah, perfect. Thank you so much.
Okay. Any other questions? All right, so I mentioned this before that the per unit prices here, we call them prices, but really they're measures of benefit. So as you move into the next chapter, you'll see them introduce the marginal benefit curve. And the marginal benefit curve is a demand curve. But what we're measuring is not the price. Well, we don't have to call it the price. We can call it how much someone is willing to pay for one more unit of good, given that they already own the certain unit of goods that we have here. So like if you already own Q1 units of good, then you are willing to pay P1 for the next unit of good. Now, if you instead owned a lot more of that unit of good, you probably would be willing to pay a lot less for the next unit because of the diminishing marginal returns. If we flip the other way and we say, well, what if you owned a lot less of that good? Well, if you owned a lot less of that good, you might be willing to pay a lot more for the next unit of it because you don't have any. But this process eventually has to end. And it ends at the so-called choke price. And the choke price occurs in this demand curve when the quantity is equal to 0. So this is saying that when you don't own any, how much would you be willing to pay for one unit, for your first unit? And that's the choke price. So if we set the price of a good above the choke price, no one's going to buy the good, or at least no one with a choke price below that is going to buy the good. So once a price swings below the choke price, then people start buying. So that's why we call it a choke price. The other point that we might be interested in is on curves that, so a lot of these curves are asymptotic. So they keep getting lower and lower, but they never actually touch the axis. But when we draw like linear curves there, they do. And so if they do happen to touch this axis, then the point that they touch at, this is a point where the marginal benefit is equal to 0. And so at that point, you have so much of the good that you're not willing to pay any more for it. So it's like the inverse of the choke price. You have so much that you're not going to buy any more of it, but you're not going to buy any more of it because the only thing you'd be willing to buy would be something that'd cost 0, and it's probably not going to cost 0. So there are two reasons to stop buying. One, it's just too expensive, and that's on this side of it. It's above, the price is above your choke price. It's above what you're willing to pay. Or you have so much of the good that you're willing to pay 0 for it, and so everything is above that price. And so you either stop buying because you have too much, or you stop buying because you can't afford the first unit. So that's the way in which we interpret these things.
Which one's the version where you're going to have too much? The marginal benefit is...
That's when the marginal benefit is 0.
Okay.
Yeah, there's no benefit to the next one. At the choke price, the marginal benefit is high. The next unit is PC important to you. You're willing to pay the most you are ever willing to pay for that. But it just so happens that the market price might be above that. And so if the market says, yeah, you say, I'm willing to pay $10 for this green ball, and the market says this green ball is worth $11, then as much as I love this green ball, I play with it all the time, I'm not willing to pay $11 for it. It's above my choke price. Now, if it's $5, I might buy 2 green balls or a green ball and a fidget cube. And so I can put those things together. And so as you lower the price, I'm now willing to spend more.
Okay.
Are there any other questions about that? Okay. So now that we're comfortable with that, we know the choke price is how much I'm willing to pay, how much I value, how much I'm willing to pay for the first unit. All right. Now I have to pay for that first unit. I have to turn over money. That money that I turn over is opportunity cost. It's lost benefit. You may not view money itself as being beneficial, but money is potential to buy other things. And so when I give someone my money, I am taking away from me potential benefit that I could have got from spending the money somewhere else. And so, what I view here is that the benefit that I get is actually the difference between how much I'm willing to pay and how much I actually paid. So it's this difference here, the marginal benefit versus the marginal cost. So you can view the marginal benefit as PC and the marginal cost you can view as the actual price. And then the so-called marginal net benefit is what's in between. And so that's actually what I'm getting out of it. I was willing to pay $11 or $10 for this. You charged me $4, so I get $6 of benefit out of this. Now, once I bought one, then I don't get the same benefit out of it. My benefit goes down. So I won't be willing to pay as much, but still, if I'm willing to pay more than what you're charging, I might buy a second one. But the benefit I get from that second one net is going to be less than the net benefit I get from the first one. And that's what we're kind of showing here with this curve. So that's our marginal net benefit. And that's kind of where your chapter 2 is going to start out. It's going to start out with this example of you're going away on vacation and you're trying to trying to decide between these different vacations. You know how much you'd be willing to pay, you know how much each vacation costs, and so how do you choose the right vacation? And they make the argument that you choose it not based on how much you're willing to pay, but based on what kind of is the net benefit. So how much do you get out of it, given that you're going to have to cough up a certain amount of money? And that amount of money should be significantly less than the maximum amount of money you'd be willing to cough up for it. And that gives you the maximal benefit. That's what we're showing here. So again, if I buy one green ball, I'm going to put it down here, it's green. The second green ball, I get less benefit out of, even though it's the same price. The third green ball, even less. The fourth green ball, even less. Eventually, I get no net benefit out of buying more green balls, and I come out and I say, well, I got 4 green balls, and I got the max benefit I can get from buying these green balls. I'm done. And so if we want to add up all of the benefit of all of these green balls together, that's the so-called consumer surplus. And that is the area between the demand curve and the price that you end up paying for it at your kind of equilibrium level here. And so I end up buying however many green balls fit underneath here. Let's say 4 green balls. So let's say that this Q is equal to 4 because I've got my 4 green balls. And the first one I got a lot of benefit out of. The second one, not so much. The third one, not as much. The fourth one here. The fifth one, if I were to buy the fifth one, it would be like an equal trade. I might as well just keep my money because I'm not going to get this. I'm not going to get the price out of it. So I might as well just keep the dollars and I could buy something else with that. So, so my quantity is equal to 4 and the area underneath this curve is the total benefit I get from this good, which is just the summation of the benefit I get from all 4 green balls that I got. A lot of benefit from the first, less for the second, even less for the third, even less for the fourth. They all add together. That's the joy that I get from this, owning this type of good. Okay. And so if I give you a kind of a curvy shaped demand like this, sometimes it's difficult to calculate that without some calculus, because I might have to give you a function, you might have to take an integral under a curve, and I'm not going to, this isn't a calculus class, and so we're not going to take, go into in-depth on integrals and things like that, but instead I will give you demand curves where you can use geometry to estimate these things. So in this particular case, this to me looks like a triangle. It's got one leg of the triangle, a hypotenuse, and another leg down here. And so I can call this the base of the triangle. I can call this the height of the triangle. And if I were to calculate the height and the base just by looking at the graph, then I can use this formula, 1/2 base times height, and that will give me a good estimate of the consumer surplus. And that number, which will be in dollars, remember, this is in dollars per quantity, and this is in quantity. So when you end up taking the area, you're multiplying the two of those. And so you get dollars out. And that area, which will be in dollars, will be the total, I will say it's the net benefit that you get from this good as a whole. It is the consumer surplus. It is the how much extra joy you get for a good that's priced at this value. And if this is a aggregate demand, it's how much joy society gets from a good priced at this value. All right, are there questions about that? All right. All right, because it is a triangle, could you also use, you could, because it is a triangle, you could also estimate the length of this chord here, I guess, so that, but it turns out that that length ends up not being, it doesn't map to anything like physically interesting or useful, but the area underneath here does. And we will see that as we move into the next chapter, and maybe the chapter after that, we actually see that, that the area underneath there is equivalent to the accumulated benefit that you get from a good. Whereas the line, that hypotenuse that you could calculate, it might be useful to calculate for some geometric things, but it turns out for triangles, all you really need is the base and the height to get that area. And it's curved, and so there is a chance that it is not precise. And so, you know, the way the pros would do this, the professionals would do this, is they actually would get a good formula for this curve, and then they would take the integral underneath this curve and subtract off the area underneath this price. And so they would effectively take the integral from the curve all the way down to the axis, and they would subtract off the integral from the price all the way down to the axis, and then they could actually solve for exactly what this area is. Here, we're just going to approximate it with a triangle. Okay. Any other questions? All right, great. So at the end of the chapter that you've already read through, then they talk about aggregating demand together into market demand. So I mentioned demand functions. They map price to quantity, right? I hope I got that right. And so we would like to know how a market, so how a society, if I change the price of things, how is a whole group of consumers together going to change their quantities? How much? And so in order to get that, in theory, I could take everybody's individual demand curves. So, so person 1, person 2, person 3, person 4, and I should be able to bundle them together into an aggregate demand curve. And so the market demand is basically exactly this formula here, is that everybody shares the same price, but to add up all of the quantity that all of the market buys, then we just add up the individual quantities. This is how much person 4 buys, this is how much person 3 buys, and so on. So it's the total, sort of the sum of the individual demand for a product across all for the market. But you have to be really careful when I ask you questions about the market demand, because you have to know what's the choke price. So what's that, that I'll say P choke or PC, P choke, for each individual. And if the choke price is too high for a given individual, then that means that that individual is not in the market. So it's as if that individual doesn't exist. Until you bring the price to a low enough level that that individual starts buying, we don't add them in. So I can show that graphically, where if I look at this market demand curve, I can imagine that I have 2 choke prices. So some individuals have a choke price of PA, and some individuals have a choke price of PB. And the market demand will end up looking like it has this knee. it kind of looks like it's got one slope, and then at some point, it then has a different slope. And what's happening here is that you have one up here, you are only adding those individuals who are willing to pay above PB, but not willing to pay above PA. So there might be only, say, 2 individuals up here, but maybe all 4 are down here. And so that's the reason why we get a change in shape, is that up here, if you were to change the price of the good, so let's say you were to increase the price of the good up here, then your change in quantity is going to go from here to here. So here, if I were to increase the price of the good, I get this small change in quantity. It's relatively small, right? But down here, if I make that same change in quantity, so let's say this is the same change in quantity, then if I look, I'm sorry, same change in price, then if I look, I get a massive change in quantity. Now, to make sure, see if everyone's paying attention, why? Why between these prices do I get a small change in quantity, but for once the price becomes sufficiently low, then why do I get a much bigger change in quantity? Does anybody have a quick guess? And the key is how many people are involved. Because more people can afford it. That's an excellent answer. Up here, there's only 2 people involved in the market. So when you change the price, you're only really going to see the decisions of 2 people. Down here, 4 people are in the market. So when you change the price, 4 people make decisions. And that additional number of people making decisions is the additional quantity that's sloshing around. And so that's why the demand curve goes from being steep to being shallow, is that the market demand curve took on more people as the price got lower. So the society demanded more at lower prices because more people got interested. Okay. Are there questions about that? Okay. So choke prices and how to aggregate these things. The book refers to horizontal addition, which I think we'll talk about when we hand do some examples in the lecture size B5A. All right. So the last thing we're going to cover today, in the last, say, 10 minutes here, is the notion of elasticity. And so elasticity is a term that economists use to represent how something changes when something else changes. And it's usually how the quantity of something changes when something else changes. So when the income changes, how much does the quantity of purchase change? When the price changes, how much does the quantity change? So the elasticity, something that is elastic means that when you change the price, then you change the quantity in a great amount. So something that, a rubber ball is elastic because when you change the force, it changes its shape. And then if you let go of the force, it returns to its own shape. It's elastic. And so it is very responsive to changes. Something that is inelastic is something that you push on, but it doesn't change very much. You change the income or change the price, but quantity doesn't change. So that's inelastic. We are going to start focusing on demand elasticity, which is how much the quantity demanded changes when you get the change in some other quantity, and we're going to focus on price. So the thing that demand elasticity is how much does demand change, or quantity demanded, And what we focus on is specifically the price elasticity of demand, otherwise called the PED, or PED. And so this is the relative change in quantity, which you can view this, we'll call this delta Q divided by Q, and I'll write this out here in a second here, divided by the relative change in price, which you can view as delta P over P. So for what percentage, so if price changes by this percentage, that's in the denominator, what is the corresponding percent change of the quantity, the good that I'm focusing on? That's in the numerator. That's the price elasticity of demand. And so it has roughly this formula where if I consider two quantities and two prices, then I'm basically saying, well, if I'm at this quantity here and I were to increase the price this much, and I were to then, that would cause a shift in this quantity here, then that would end up resulting in a delta Q and a delta P that I would then normalize by this Q and this P. That's what's kind of being shown here, is that you say percent relative to what? Well, this is the delta Q, this is the change in quantity, but then I divide by the original quantity, and this is the change in price, and I divide by the original price. And that's roughly the idea of PED, but we want to get rid of the need to use a second quantity or a second price. So like we did in calculus, we want to somehow compress this onto a single point. And so what we're going to do is we're going to say, well, this is the formula that I just wrote there. So what I'm going to do is I am going to play with the arithmetic a little bit. So instead of delta Q divided by Q and delta P divided by P, it's equivalent to say it's delta Q over delta P times P divided by Q. So I just did, this is again just delta Q divided by Q, but I just separated the fractions out, and this is equivalent. And so now that I have this here, then I can start thinking about the slope of the demand curve at this particular point, P and Q. And so that slope of the demand curve is represented by this delta Q over delta P. And the actual amount of price in Q is in this second fraction over here. And so we are going to then make this more general, and this is where the calculus comes into place. We then say, we're going to call it the partial derivative of the demand function of Q with respect to the partial derivative of P. But in the end, really all I mean by that is the slope of the line, where you're considering how much does Q change if you change P. So we write it like this formally, but in almost all of our examples, you can think of this as delta P over delta Q. And really, you can just draw a line and that's tangent to that point. And then you can take the slope of that line. And that slope, delta Q over delta P, is exactly this thing right here. That's all we're doing. We're kind of graphically taking derivatives. So for most goods, the PED is going to be negative. So unless they're Giffen goods or inferior goods, then the PED is going to be, unless they're Giffen goods or Veblen goods, the PED is going to be negative. And so PED is technically negative, but it'll often be portrayed as a positive value. Or in other words, economists will put absolute value signs around all of this. And so in your homeworks, I will generally tell you that I'm okay with positive or negative here, but just know that formally it's negative. Now, the other thing I want to point out about this is I called this a slope, but note that the kind of dimensions are flipped in terms of rise and run. So although this is the slope of this tangent line, we're going to call the quantity, we're putting that in the numerator. So the thing that is the run of the slope is end up actually being in the numerator here. So PEDs tend to be high when this slope drawn this way is flat. So it's a little flipped. And that's just a matter of convention because demand curves are drawn this way and PED is written this way. You just have to kind of flip in your head rise versus run. And so if you were to calculate these things for any given quantity and price, if the slope of the demand curve was somehow perfectly vertical, we refer to that as being perfectly inelastic. That means that quantity doesn't change even though price does. You could charge whatever you want and I'm always going to buy exactly the same quantity. That's going to happen very often if, say, I have a high income and it's a cheap good. You can make that thing less, a little more expensive, but it still is a small fraction of my income. So I'm pretty much going to buy the same amount. I'm not going to pay attention to the price. It can be inelastic where you start paying attention to the price a little bit, but you have a greater percentage in price change than you do in the percentage of quantity change. So you get a 5% increase in price, but only a 1% increase in quantity. That's what we mean by inelastic. It can be unitary, which means that you get the same percentage out as you get in. A 5% change in price gives you a 5% change in quantity. And then it can be elastic. Elastic means that I only change the price by 5%, but the quantity actually changes by 10%. So it's an even greater change. So something that is elastic is something, and something that's perfectly elastic is a weird sort of made up good where it's kind of an asymptote. You never actually get to perfectly elastic, but it's kind of the ideal of elastic where small changes in price lead to gigantic changes in quantity. All right. And so in the last couple of minutes here, I'll just kind of just showing off this graph here. So when you think about this through here, there's two things you need to think about on the demand curve. It's the slope of the demand curve and the particular point that you're sitting on. And so the slope of the demand curve is the first factor, and the actual points that you're sitting on are the second one. So as an example, if I were to say make the demand curve flat, I'm making the slope constant, but the P divided by Q ratio is going to be high here, moderate here, and low down here. So even though the slope of the demand curve is constant, the elasticity goes from being high up here to being low down here. So it's not just the slope of the demand curve, it's both the demand and the particular quantity. And so if we had more time, we'd go through these examples, but I start off the next lecture with talking about example cases of these. And so this is just a preview of that next lecture, that B5A. And just for food for thought, there's also an income elasticity of demand. So that is how much quantity changes if your income changes. And what I was trying to get at, if we had more time here, is I would try to get out of you that for an inferior good, then as your income increases, you get a decrease in the amount of the good, whereas in a normal good, you get an increase. And so there's another type of elasticity called income elasticity of demand. You might call it IED. And for that one, it's negative for inferior goods and positive for normal goods. And then as a take-home food for thought, there's also something called the cross price elasticity of demand. And I'll just leave that out there. This isn't something I'll test you over, but just think to yourself, why might they have this term? Cross price elasticity of demand. What do you think the cross PED might be? And you can just sort of think about that over the weekend. So reminders, we've got homework B5, which corresponds to this lecture. So you technically have enough to do homework B5, but we're going to do a lot of examples in Tuesday's lecture, which are directly applicable to homework B5. So that's what's going on here. And then also Unit C is coming up. So that's chapters 2 and 3 eventually. So activity C1 is available on Canvas. And so start activity C1 because unit C1 is a week, or lecture C1 is a week from today. So with that, let me put up an attendance exercise, and then I'm happy to stick around if there's any questions. But your attendance exercise today, I'll put the link in the chat. It's also available on the screen and on the QR code. And so what I want you to answer for this one is income elasticity for demand for an inferior good positive or negative? So income elasticity for demand. So that's what for a certain fraction, how does quantity change if income changes? So if that's my income elasticity command, which is delta Q over delta I, for an inferior good, is that positive or negative? Income elasticity of demand. And with that, that's all I have for you for today. So if there's any questions.
You
Go
said
ahead.
if it's for an inferior good for income elasticity of demand, what's the sign?
Yeah, I'll type it in the chat. For an
Okay,
inferior good is income elasticity of demand. Most of what we're talking about is price elasticity, positive or negative.
Thanks so much. Have a great weekend.
No, you too.
Can I ask a question real quick? I'm sorry.
Absolutely.
Just me not picking this up. But I know you went over that slide a lot that had the final equation for price elasticity of demand. I guess what I was wondering is I think there was like 3 versions before you got to the final one of like different ways, but I was wondering if you could either go back and explain that part real quick and like the significance of each of those little versions before you got to the final highlighted one.
Yeah, right. So the all those other versions, that was just
not those ones. I remember
right.
that, but if it was before,
there was like
yeah,
where
like
we started.
Mm-hmm.
Yeah, all this was just trying to walk us through the derivation. So the ultimate, like if you go to Wikipedia or something like that and look up price elasticity of demand, this is the formula you get. And so what I was trying to walk through there, and I didn't mean to cause more confusion, I apologize if I did, was where the heck does this formula come from? Mm-hmm. And so if we walk backwards through this formula, then what we end up seeing is we say, well, we get rid of the derivatives and we turn them into these little deltas. And if we get rid of those little deltas, then we take those deltas and we move the P and Q up into the fraction. And then what we end up seeing is that formula is actually representing what is here, which is the relative change in quantity and the relative change in price. And so that's all I was trying to say, is that this funny formula here is just a sort of a way that's after some rearrangement. This really is just the relative change in quantity, delta Q over Q, the fractional quantity, divided by the fractional change in price.
Okay, perfect. Thank you. No, you didn't cause more confusion. I guess I was trying to just see, like I wanted to know that thought process too, because it might make it easier for me when I'm trying to calculate something. So thank you.
So basically what you were trying to say is just like, this is what the broken down version of this looks like, but but the real version shows the derivative version of Q and P. But this is like
that's right.
So if we were to like figure out any problems or measure something out, it would be better to use the relative change, like the, how do you say it, the expanded version of it, because for me it's easier to understand if we do the Q1 minus Q0 divided by Q0 and for the denominator. I think it would be easier for me to understand that one than the derivative itself.
Well, if I just give you a demand curve, then what you'll end up seeing is that I might say, okay, here's a demand curve, here's a price, here's a quantity, calculate price elasticity. And at that point, you need to know the slope of the demand curve, which is effectively this first term. And if you know the price and the quantity, then you can calculate this thing up here. And so it may be that if I give you a demand curve, you just have to use this, because there's no, like, because there's no easy way to sort of build this one if I've only given you one price and one quantity. This one, in order to get kind of a delta Q, I kind of need to give you two quantities and two prices,
Oh, okay.
and then have you calculate what the change was. But if I don't give you a change, if I just say, what's the elasticity at this point, then you're kind of stuck with using this real version. But I could ask you, and as I do, in fact, in the homework, if price in, like, I'll just say that there's a good out there and price increased by 2%, but the quantity demanded increased by 4% or decreased by 4%. And then I would ask you, what is the price elasticity of demand? And in that case, you're effectively using this thing over here because I've given you the delta Qs.
Yeah,
I've given you the
yeah.
delta Q over Q. Go ahead.
Okay, yeah. So if you've given us like a secondary thing, you can use the delta Q and PQ. But if you just given us just a single curve, we have to find out the slope first, which is rise over run, but it's flipped, and then we can multiply with P over Q, and then we'll have our PED, our relative PED.
Exactly.
Okay.
You've got it. Very well said. If I give you percentages, you can use the old school one where it's just percent over percent.
Mhm.
If I give you a curve, then you're probably going to have to find a slope and then use this formula.
Okay. All right. Thank you.
Mhm.
And we're going to be going over like and you said in the next lecture the questions we have in the homework B5, they're similar to the ones that we're going to have going over in lecture next week.
Right, yeah, we'll do some examples in the Tuesday lecture of next week. And I've already also put, if you look under the homework on Canvas,
Yeah.
underneath it in the module, there's some example problems worked out as well.
Oh yeah, the ones that were from like a couple of years ago, but they're some similar solutions, something like that.
Right, right. I've got the homework, the homework from the same position last year, and a homework from another instructor from like 2 years ago. So actually, two homeworks from that instructor. So there's so a lot of ways you can see these applied.
Okay. And also for the this is one last question, sorry. So to answer these type of questions that you're giving us in the activity, it all has to be typed out or like how
As long as it has to be readable and clear in one document. So it has to be the point where the grader or the TA could just pick up that document and then just be able to very quickly find your answers. Like, so I mean, like, it's fine to have your work on there, but like, just make sure that it's legible, that your answers are on there, that it's clear for the grader to find your answers, and if she needs to follow your process of looking through your work. So if you can put that in an electronic format, that's great, because that's probably going to be the most legible, and that's probably closest to the deliverables that you'll be responsible for doing when you're released out into the world. But if it's really tedious and you'd much rather do it handwritten, that's okay. Just make sure it's legible both when you're doing it and however you're scanning it in and uploading it.
Okay. All right, thank you.
Mm-hmm.
You have a good weekend.
You too.
Goodbye.
Anything else?
No.
See you.
Bye.
All right, in that case, I will end the meeting.